Hi guys, this is Mr. Mundo, and today I want to go over the rate of change, which a lot of you were asking me how to calculate the rate of change. And as well, I noticed that some of you were actually struggling with actually finding the right way to calculate the rate of change. So we went over the rate of change already. We took notes and we did some examples in class. However, I understand that for some of you this might be complicated. So as a result, I decided to make this into a video so that you can actually understand how to calculate the rate of change. And in order for us to understand the rate of change, we must start with the formula. So the formula you're actually looking at here, it says the change in value on the top, and it's divided by time. And this same exact formula you're looking at that I'm showing you at this moment, it's actually from the page 1. So on your Earth Science reference table, if you go to your Earth Science reference table, you can actually find the rate of change formula, the same exact formula that you're looking at right here on page 1. But I think one of the best ways to actually understand the rate of change is by doing it as an example from our quiz. So here we have our quiz that we took earlier in class. We have one of the questions from this quiz. It actually says calculate the rate of change in the average monthly temperature for Omaha during the 2-month period between October and December, as shown in the graph on the right. So first, before we actually show our work and before we actually calculate and get an answer for the rate of change, we must understand what we're actually dealing with. So here we have the average monthly temperature. By looking at this graph, we see that there's at the bottom we have the months, starting with December, January, February, March, all the way to December. And then here we have on the left, the y-axis, we have the average temperature. This is in degrees Celsius, by the way, so that's really going to be important. Notice that we go from 0 to 4 to 8 and then 12. So it looks like each square, it goes in a set of 4. So from 0 and then plus 4 is 4, and then plus 4 is 8, and then plus 4 is 12. So it's each square here, it's has a value of 4. Whether here it just has a value of 1, because from December to January it's just 1 month, and then from January to February that's another month. It's just 1 month, and then 1 month, and then 1 month. So that's what we know. We also know that there's two lines. There's one that it's for this, which is Omaha, and then we have another line that it's right here, and that's for Eureka, which, by the way, both of these are actually cities in the United States. So now that we know this, we know that these are the monthly temperatures from December to December for the city of Omaha and from the city of Eureka. Now that we know what we're talking, what we have in front of us, now we can actually understand the rate of change. So the question says for you to calculate the rate of change for Omaha. So we're literally going to be working just on this line. We need to ignore Eureka. I know it's there, but we're not going to work on this just for this question. I know on your quiz there was another question about this, but as of now, we are just going to work with this line, which is Omaha. And then it says during the 2-month period between October and December. So let's find October. October is actually here. You see an O for October and then D for December right here. So what we're actually, so we have, let me just show you the graph a little bit bigger. And where is October? So again, here we have the line that we're working for Omaha. And we're trying to find the rate of change between October, which by the way, it's right here, and December, which is actually here. So we're trying to go from October, this to here. And the rate of change should be from here to here. So it's like rise over run, just like the formula that we went over in class. I was telling you, we need to calculate the rate of change by understanding the rise over the run. So basically from October and then to December right here, right? That's what we need to do. So in order to do that, what's October's average temperature for Omaha? Well, we kind of like just gotta go to the left and see, and what does it say? Yes, it's 12. So that's for October. What about December? What does it say? So the rate of change, before we actually go over December, we need to put that it's 12. And then because we are going down, because it's the formula for slope, According to math, it's y2 minus y1, right? Right? Yep. So eventually we have 12 minus, and then we don't know. We just have a value. We know that it has to be another number. Well, we know how to find the other number because we are going from 12, which is here, October, to here, December, which, by the way, what is it? Yup, it's actually -4. So what is 12 minus -4? It is 16. It's very important that you know how to calculate your numbers. Now, we are going to be going from October to December. So we got 16. And then how much is it from October to December? Well, it's 2 months, right? Because from October to November, that's 1 month. And then from November to December, that's 2 months. So eventually we're going to have to divide 16 divided by 2. And 16 divided by 2 is how much? Well, it's 8. And that's the answer. Now, let me just show you before we actually go to the final answer. There's another way how you can calculate the rate of change. Now, you need to calculate. So this is how you must find you must write it in the box that you were provided with, which in this case, it was this here, which says show all the work in the box below. Everything that I've just been showing you, that's what you need to do. So here we are back where we just left off. And eventually, another way how you can also, besides just doing the calculation 12 minus -4, you can also count, because if you know that you're going from here to here, because it's a rise and then over the run, you just go from here to here, and if you look, it starts at 12 and then it goes to 8. And so how much is from here to here? Well, earlier we said that it was 4. So from here to here it's 4, and then from here to here it's another 4, so that's 8, and then plus 4, so that's 12, and then plus 4, so that's 16. So that's another way to go from here, rise, we know that there's 16, and then you divide by 1, 2. So that's exactly what we had on the next following slide. 16 divided by 2, exactly, and then you get 8. Well, the final answer has to have units, especially for this class. So this would just give you half of the credit for this answer, unless you have units. Now, how exactly do we know what are the units for this class? Well, we are going back to the question that I'm showing you at this moment. It says calculate the rate of change in the average monthly temperature for Omaha. So it has to be, temperature has to be first because we're looking for temperature. So in this case, where we are at 8 degrees, well, 8 degrees what? Fahrenheit? Is it Celsius? Is it Kelvin? Oh, here we know that it's 8 degrees Celsius, and it's gonna be in a matter of, what's the other axis telling you? Yeah, in this case, it's 8 degrees Celsius per month, and that will be the answer. That's the answer for the rate of change. So hopefully this video helped you understand the rate of change a little bit easier. Eventually, if you want, now for the next question, which has to do about the other line, which is Eureka, you follow the same idea, the same pattern, the same formula that I gave you about rate of change, which is the change in value divided by time. Hopefully this helped so you can better understand how rate of change works and how we can apply it in different ways in graphs and calculating it as well. Okay? Goodbye.